Hello, myself Sanjay Bhardwaj. Topic of discussion of this video is functions in C. Modular programming is an approach in which large programs are divided into smaller parts or modules. These modules are developed separately and then combined to form complete program. Since C is a function-oriented language, here the program is divided into smaller parts that are functions. These functions are developed and then combined to form complete program. So topic of discussion of this video is those functions in C. What basically a function is? Function is a small program which receives value, performs calculation and give back result. In C, functions are divided into two categories. One is user-defined functions and another one built-in or standard functions. As the name suggests, built-in functions are those which are available with compiler and can be directly used in user's program. However, user-defined functions are created, used as per the requirement of the user in the program. So, our discussion will be based on these user-defined function. When we say using a function, there are three aspects which are related to this. That is, defining the function. Another one is declaring the function. And the third one is using the function. Defining the function, declaring the function, and using the function. We will discuss these three things related to these user-defined functions in C language. We will start with the first one, defining the function. Function definition means giving the logic of the function. Function is defined as follows. It is given as type, then name of the function, then arguments. In braces, we give logic of the program or body of the function, then return expression. We will discuss these points. The first one is type. This is type of the function value returned by the function. Say a function is calculating integer type value. The type of this function will be int. If a function is calculating real value, type of this function will be float. For example, I say we will be using a function to find HCF of two numbers. The result of HCF will be integer type. This type will be int. Say we want to find average of three numbers. Average will be in real format. If the value is real, the type mentioned here will be float. Next one is name. Name is any identifier which is used to identify this function. Identifiers are specified as per the rules of C language. Arguments. These arguments are formal arguments. These are used as inputs of the function. But in some case, these can be used as output also. So arguments are formal arguments used as inputs of this function. The logic of the function is given in these statements. And this is what the body of the function is. The last one. This is return expression. Expression is the result returned by this function. If this type is int, this expression will be of integer type. If this type is float, the expression will be of real type. Now in some cases, there can be function that does not return any value. C language has a special data type, void, which is used as type of the function that will not return any value. In that case, this return statement will be used without expression. Even this return statement can be skipped from such logic. However, it is a good practice to use return statement without expression rather than completely omitting this return statement. So, this is type of the result given by the function. This is identifier to identify this function. The next one are the formal arguments which are inputs to the function and in some cases may be used as outputs also, and then result of this function. By using one example, we will consolidate over these concepts. Say, I want to define a function to find HCF of two numbers. We understand for finding HCF of two numbers, we need two inputs, that are the numbers whose HCF is to be calculated. Result type, it will be integer. The first point, that is type of the result. The next one is name of the function. Say some identifier, that is to identify this function. Now I said two inputs. These will be given as arguments. Say first number and the second number. The important thing is type must be given with each identifier separately. In this case, integer the first one and the integer the second one. Now the logic. This logic will be given in braces. Say R. R is the variable used for remainder. Logic says R is equal to A percentage B. Now we calculate HCF by using these steps. The process will be repeated as long as the remainder is not equal to 0. A will be equal to B. Say B is equal to R and R is equal to A percentage B. And the last step, that is return result, and that result is HCF of the two given numbers. Here it is indicated as variable B. B is the divisor that will produce result equal to 0. Type of the result. This is name of the function. These two are formal arguments which are inputs of this function. Logic of the function, and the last step is return, that is result of this function. To consolidate these facts, let it be another function, and that function is to find average of three numbers. Now I said average of three numbers can be real type, so the type of function will be float. Again, identifier, say it is average, and number of arguments which we will be giving, say float A, it can be second float B, and it can be third one, and that is float C. Type, name and argument. Logic, that will be the result. We can write return A plus B plus C divided by 3. Now, from these two functions, one thing is very clear. The logic of function can be number of statements to find out the solution, or even it can be represented in the form of a single statement that is giving a result of average of three numbers. So with these two examples, we are very clear what these values are representing. Say this is type of the result. In this case it is integer, but in this case it is real type. Name, as per the user's requirement. Arguments, these are inputs of functions, and then logic of the function and the result given by a function. I said void is used as a type of the function that will not return any value. I want to write a function that will check whether a given number is even or odd. We understand that a number divided by 2 will be even number, and number which is not divisible by 2 will be an odd number. So I want to write a function to which a number is given, and function will print a result, either it is even or it is odd. No value is to be returned back by the function. If no value is to be returned back, the type of the function should be void. Yes, we will be writing type of the function as void. Name of the function, say I say even odd. Input of the function, the number which is to be checked for even or odd value. Logic. It is if n%2, to check whether a number is divisible by 2 or not, we will find remainder after dividing the number by 2. If this remainder is equal to 0, simply we will print that this number is a even number. Printf statement will do this process, that is even. Else printf, this statement, this function is odd. End of the logic. I don't want to return any value. That is why return statement is given without any expression. This void is indicating this type, that the function is not returning any value. So this was the first part related to the use of function, and that is defining a function. To use a user defined function, first it will be defined in your program. The next part is declaration. Declaration is a statement which gives, first is name of the function. Second, it indicates type of the result given by the function. Third, it gives number of arguments. And the last one, type of the arguments. I said declaration will give name of the function. It will give type of the result returned by the function. It will indicate number of arguments. And the last will be type of argument. Declaration of the function is also known as a prototype of the function. I used 3 functions. First was for HCF, the second for finding average of 3 numbers, and the third one to check whether a number is even or odd. I say the declaration of these 3 functions. The first function, the declaration will be int, the name of the function, and int, comma int. I hope the name of the function, it is clear. The name of the function is HCF. Type of the result, it is clear. The type of the result is int. This function will be using 2 arguments, one and the second one. And the third point is the type of arguments will be integer and integer. So function prototype or function declaration will be explaining 4 things: name of the function, type of the result, number of arguments, and type of arguments. If I want to write prototype for the other 2 functions, I hope it will be float. Yes, for average of numbers, it will be float, average, followed by float, float, and float. I hope this is very simple. 3 arguments. That is why 3 times is float, and every argument is of real type, and the type is explaining that the arguments will be of real type. Result of this function will also be real type. The third one, and that is void. The name of the function was even odd, followed by argument. The declaration is explaining name of the function is even odd, type of the result is void. This function will not return any value, and int, 1 argument, and that too will be of integer type. So this is second aspect related with this function, declaring the function. The last one, that is using a function. Function is used similar to library function. There are 2 syntax which can be used while calling a function or while using a function. It can be given as variable is equal to name arguments, or we can use it like name and followed by arguments. First syntax is basically used for those functions which will be returning value, and the second one, this is used for function that will not return any value, whose data type will be void. These arguments are known as actual arguments. The arguments which are given at the time of definition are called formal arguments. And the arguments which are given at the time of using a function or calling a function are called actual arguments. The important thing is number of formal and actual arguments should be same, and type of formal and actual arguments must be same. That means if the number of arguments are 3 at the time of definition, these should be 3 at the time of using the function, and these should be of the same type. In simple words, I can say name and type of formal and actual arguments must be same. I will be combining these 3 things in a single example. Say I want to write a program, and that program is to find the value of binomial coefficient, and it is given as NCR. Mathematically its value is equal to factorial n divided by factorial r n minus r factorial. Now to solve this value, I need to call factorial process 3 times. Say one for factorial of n, factorial of r, and factorial of n minus r. This can be very simple if there is a library function for factorial. But C compiler does not have library function for factorial. The alternative is we can write a function. We can develop a user-defined function, and we call that function more than once to find factorial of different values. To start with, say we can write this function hash include stdio.h. Now I can define the function. It is integer. I said integer because the type of factorial will be integer. Name of the function, say it is fact, and then argument, formal argument. Yes, formal argument is input of this function. Next part is the logic. We know the factorial is calculated by multiplying the number from 1 to number itself. I hope for I is equal to 1, I less than equal to n, I plus plus. This loop is going from 1 to n, and we will multiply all these values with product to find out the factorial. Return, that is result, or the factorial of number n. Now this part is defining the function or the definition of function. Say main program. In main program, I want to calculate value of NCR. I need 2 variables, say for n, say for r, and another one for result, that is coefficient value. Along with this variable declaration, function will also be declared, or the prototype of the function will be given. And for this function, it is integer, factorial, integer. Name of the function, type of result, number of argument, and type of argument. To find NCR, I need 2 values, that is n and r. Input statement can be used scanf, %d. %d is a format used for input of integer variables, ampersand n and ampersand r. Now calculation of coefficient. Coefficient is equal to factorial n divided by factorial r multiplied by factorial n minus r. Very simple. By using a function, by writing a function once, I am using this function 3 times to calculate factorial of 3 different numbers. And the last is result, printf, that is value of coefficient. End of the logic. Now this example is giving all the 3 aspects, that is definition of the function. And I hope this line is declaration of the function. And the last one, this one is using the function. Now a simple thing comes in my mind. What is the advantage of using this function? And it is very clear from this example. I developed this code for finding factorial, and I use the same code to find the factorial of n, then factorial of r, and then factorial of n minus r. That means same code can be used number of times with different set of values. This is a big advantage of functions. Reduction of code, reusability of code, same code can be used for different set of values. With these points, I will like to close this topic. Here we discussed three things. One is defining, declaring, and the third one is using this function. Through our example in which we defined a function for factorial, we declared that function, and we use this function. Continuation of this topic will be in my subsequent lectures. Thank you.